everyone, I'm Chen. Today I'm going to talk about heavy metal monitoring in sea turtles using X. Purpose. Because it's difficult to know a heavy metal concentrations in a live species without killing them. We want to find a non-killing method to monitor heavy metal concentration. And today we focus on sea turtles. And we want to find the association between sea turtles and eggs. Why we choose sea turtles? Because they have long lifespan and high traffic levels in the marine food web. And there are very limited samples to be available. Material and method. And loggerhead turtle samples were caught in commercial fishing net at Japan, and we dissected them, then stored in very low temperature. And green turtle samples. We didn't kill them, we just collected their eggs for extend the intercross variation. And we also stored their eggs in very low temperature until chemical analysis and heavy metal analysis. Now we analyze the tissue, the sea turtles tissues and egg, and we use several methods and machines to know the concentrations of iron, magnesium, zinc, copper, lead, nickel, cobalt, cadmium, and mercury. The precision of method larger than 95%. And for iron, magnesium, and zinc, we dissolve the tissues into mixture of acid and make a non-valent solution and put it in a machine. For copper, lead, nickel, cobalt, and cadmium, because they are easier to be interfered. So before put them in the machine, we pass MIPK TDTC treatment. And for mercury, we put the solution into the other machine. Now let's see the heavy metal concentration in muscle, liver, and kidney of loggerhead turtle. In this table, we compare the concentrations of heavy metals in 3 tissues. Concentration of iron, magnesium, copper, and mercury were highest in the liver, and nickel and cadmium were highest in the kidney. And concentration of zinc are the same in 3 tissues. And lead is below the detection limit. Now let's see a comparison of heavy metal concentrations in eggs. We separate egg into 3 parts: yolk, shell, and albumin. And why is this? It means egg whites. And now we follow the means, we can know that concentration of iron, magnesium, zinc, mercury, and cadmium were highest in the yolk, and concentrations of copper were highest in the shell, and concentration of cadmium was detected only in the yolk. Now let's see a coefficient of variation. What does this mean? If this number is high, it means this data is very different. And in the other hand, if this number is low, it means this number is very similar. And we can see the essential element like iron, zinc, and copper is lower than non-essential elements, because the essential element is very important for embryonic development. So the essential element fluctuated to lesser extent than non-essential elements. Now let's see the percentage composition of heavy metals in shell, egg white, and yolk. In this picture, we can see that heavy metal were almost in the yolk, so yolk is the most important part for examine heavy metals. Now let's compare the eggs from same mother. This. And x-axis is distance of glauca, and y-axis is heavy metal concentration. And we can see that there are almost no wave, so concentration will not influenced by egg-laying order. But why cadmium and mercury fluctuated more? Because concentration of cadmium and mercury were close to detection limits, so the error were larger than others. Now let's compare the eggs from different mothers like this. The axis is large number, and y-axis is heavy metal concentration. And different line means different sea turtles. And let's see the y-axis. The concentrations of different heavy metal were very different, and the order is iron larger than zinc, larger than copper, larger than lead, larger than mercury, and larger than cadmium. Now let's see the heavy metal equation VIX. What is heavy metal equation rate? It means all heavy metals in X divided by all heavy metal in whole body. And let's see heavy metal equation rate. Can see that they are lower than 3%, even lower than 1%. So we can say egg laying is not major root of heavy metal elimination in sea turtles. After so many results, now let's see how to use egg to estimate the heavy metal concentration in female sea turtles. We use the ratio of tissues divided by yolk or whole body divided by yolk. What is tissue divided by yolk mean? If this number is low, it means the concentration of heavy metal in yolk is similar with tissues or whole body. Now let's see a whole body divided by yolk ratio. We can see the essential elements will transfer from mother to X because it's important to embryonic development. And the non-essential element will limit to be transferred from mother to X. Now let's see a coefficient of variation. If coefficient of variation is low, it means this ratio have more representative. Yeah. And we can see that the zinc is good for examination in street tissues and whole body. And conclusion, heavy metal concentration were uniform within and between clutch of loggerhead turtles. And estimate the heavy metal concentration between X and female is possible. Although this paper didn't have a clear answer or conclusion. Yeah. and using X which failed to develop to monitor the heavy metal concentrations, instead catch endangered species. Thank you.